पे क्या करना है? लाइव पे जाना है?
यूट्यूब पे लाइव बिल्कुल।
ओके। नेक्स्ट, नॉट मेड फॉर किड्स। देखें यूट्यूब पे, आप देखें यूट्यूब पे, देखें आया
जी जी आज तरफ आ गए
और स्क्रीन शेयर हो गई।
स्क्रीन शेयर होगी बिल्कुल। मैं आपको ये फौरन से नई लिंक भेज देता हूँ ताकि आप ये फॉरवर्ड कर दें।
भेजें। मेरे पास क्यों नहीं आ रहा यूट्यूब पे?
क्या चीज़ है?
अच्छा, ये मेरी आवाज़ वहाँ पे आ रही है यूट्यूब पे या फ़ोन पे आ रही है आपको?
नहीं यूट्यूब पे।
यहाँ तो मैंने आवाज़ बंद की हुई है। चलें जी, हो गया, ठीक है ठीक है। अब मैं स्टार्ट करता हूँ से।
ठीक है सर, मैंने आपको लिंक भेज दी है।
परफेक्ट, जज़ाकल्लाह। ओके, अल्लाह हाफिज़।
ओके अल्लाह।
बिस्मिल्लाहिर्रहमानिर्रहीम। सल्लल्लाहु अलैहि वसल्लम। अल्लाहुम्मा रब्बि ज़िदनी इल्मा। सल्लल्लाहु अलैहि वसल्लम। आमीन। अल्हम्दुलिल्लाहि रब्बिल आलमीन। Good afternoon, everyone. I hope you are all doing well and your preparation of S2 is going smoothly. So first, I will discuss some important concepts of testing of hypothesis. I will take only 10 minutes in summary because I have to spend more time on questions. I will share this file after this lecture in the description. So, hypothesis testing. Hypothesis testing means a claim that we want to test. H0 means null hypothesis, and this is the current situation where H1 is alternative hypothesis and this is the new situation. And it is the claim usually. Not always. Alpha percent is the level of significance and X means the test value. So we must know these terms. Types of tests. We have three types of tests. Number one, upper tail test. Number two, lower tail test. And number three, two tail test. In upper tail test, we do this test when we are looking for an increase in H1. Or we can say when H1 involves a greater sign. So if we have H1, let's suppose P is less than 0.2. So, H1, P is greater than 0.2. Since H1 involves a greater sign, so we will perform the upper tail test. And it means we are looking for an increase in H1, greater sign. Lower tail test. We do this test when H1 involves a lesser sign, when we are looking for a decrease in H1. Two tail test. We do this test when H1 involves a not equal sign, meaning when we are looking for a change in H1. This is for discrete distributions, and discrete distributions means binomial and Poisson. This is the accepted region. This is the critical region, and this is the boundary of critical region. Critical region means a region where we reject H naught, or a region of small probability, a region of rare events, you can say. So critical region means a region of rare events, unique events, and its probability is very small, usually 5% or 2% or maximum 10%, which is alpha percent. So here we reject H naught, and this is the accepted region, and here we accept H naught, and this is the test value. So if test value lies in critical region, then we reject H naught. Otherwise we accept H naught. And this is the boundary of critical region. This is an example. If H naught is P is 1 upon 6. Remember, in H naught we always write equal sign. In H1 we never write equal sign. We can write greater, lesser, or not equal. And this value of H naught is not known as P naught, and we use this value in calculation. So if H naught is P is 1 upon 6, let's suppose a fair die. When we throw a fair die and the probability of a number 5, let's suppose, is 1 upon 6. And if P is greater than 1 upon 6, that means the die is biased. If P is 1 upon 6, the die is fair. And this is the claim. So if the test value lies here, then we will reject H naught, and we will conclude that the die is biased. And if the test value lies here, then we will accept H naught, and we will conclude that the die is fair. I have mentioned these things here. Now type 1 and type 2 errors. I already have told you that I will spend more time on questions. I'm just recapping this thing. So type 1 error. A type 1 error occurs when a true H naught is rejected. This is very important. Remember this. When a true H naught is rejected, then a type 1 error is occur. So here we reject H naught in this region, critical region. So type 1 error, the region of type 1 error is this, the critical region. This is the region of type 1 error. Why? Because we reject H naught here. And type 2 error, the region of type 2 error is this. Why? Because we accept H naught here. So a type 1 error occurs when a true H naught is rejected. And a type 2 error occurs when a false H naught is accepted. So this is the region of type 2 error, and this is the region of type 1 error. I mentioned this here. A type 1 error occurs when a true H naught is rejected. And a type 2 error occurs when a false H naught is accepted. I'm sorry. You can understand this with the help of this table. When we do testing, then we have two possible answers. Originally H naught is true. This is the correct decision. H naught is true originally. So if the decision is accept H naught, remember originally H naught is true, and if the decision is accept H naught, then this is the correct decision. So no error. H naught is true and the decision is accept H naught. So correct decision, therefore no error. The other possibility. Originally H naught is true. H naught is true and the decision is reject H naught. So this is the wrong decision. And this means type 1 error. Originally H naught is false and the decision is accept H naught. So this is the wrong decision because H naught is originally false and we conclude that accept H naught. That means wrong decision and a type 2 error is made. And H naught originally is false and the decision is reject H naught. So this is the correct decision. Therefore no error. So just remember this thing. A type 1 error occurs when a true H naught is rejected. And a type 2 error occurs when a false H naught is accepted. So, probability of type 1 error. Probability of type 1 error is the probability of critical region. And probability of type 2 error is the probability of accepted region. I'm sorry. Critical region. For discrete distributions, for binomial and Poisson, we always use trial and error method to find the critical region. Now continuous distributions. This is the critical region and here we reject H naught. Therefore, this is the region of type 1 error. And here we accept H naught. Therefore, this is the region of type 2 error. If the test value lies here in this region, then we reject H naught. X means test value. And if the test value lies here, then we accept H naught. I already have explained this thing. This is the region of type 1 error because we reject H naught here, and this is the region of type 2 error because we accept H naught here. Now in continuous distribution, this is very important. In continuous distributions, the probability of type 1 error is the probability of critical region and it is always alpha %. Remember, in continuous distributions, we always write alpha % as the probability of type 1 error. What if this is 2%? Then this answer is 2%. But in discrete distributions, we use trial and error method to find the critical region. And the probability of critical region is the probability of type 1 error. Now, how to find critical region in discrete distributions? Now, critical region for continuous distributions, use this formula. Z test is equal to Z critical for critical region. For example, Z alpha percent is 95%. So the corresponding Z value is 1.645. So write that value here. And Z test, the formula of Z test for population, remember for population, the formula of Z test is C, that means critical value. Let me sketch this here. This is for X, population, and this is for Z, standard normal distribution. So this value is 1.645. Now we need its corresponding value here. This is C, and we are working for this C here. So both areas are same, 5%, 5%. So for critical region, use this formula. Z test is equal to Z critical. So write in this formula C here, minus mu naught, the value of H naught. Remember, while finding critical region, always use the value of H naught here, mu naught. And the standard deviation is here. You will have mu naught and sigma in the question, and you can easily get C. This is the way to find critical region in continuous distributions. Now, types of questions. I'm just going through these. There are, you will find binomial distribution question. This is the formula of binomial distribution. This is the way to write H0 and H1. Just remember this, how to write H0 and H1 and the distribution and the formula. So this is the one type of question in testing, binomial testing you can say. This is the second type of question, normal approximation to binomial distribution. You have done this in S1. So remember, this is the condition for the approximation. Both NP and NQ are greater than 5. And you all know how to use normal approximation. You replace mu of normal by NP and sigma square by NPQ. And one very important thing, we do continuity correction as well. And remember, we are working in population. So while working in populations, we will use this formula of Z. This is the continuity correction, plus minus 0.5. And this is the mean, and this is the square of variance, under root variance. So this is the second type of question in testing. This is example, I'm leaving this because I have to discuss questions. So you can go through this later, or this is the, I have already made the lecture of this. So you can find the lecture of summary of testing of hypothesis on the playlist, and then you can just watch this. Poisson distribution. This is the third type of question. Just remember this formula and how to write H0 and H1. Use lambda. If the question is of Poisson, then write lambda here. This is the fourth type of question. Poisson approximation to binomial distribution. And remember, this is the condition. N is greater than 50 and P is less than 0.1. So we change the distribution to Poisson, binomial to Poisson. So the mean of binomial will become lambda. So 60 times 0.01 will give you the value of lambda, and you will substitute this here. So this is the Poisson approximation to binomial distribution. Now this is very important. normal approximation to binomial Poisson distribution. Remember the condition, lambda is greater than 15 for the approximation. So if you are solving a question of Poisson and if you get lambda greater than 15, you have to use normal approximation. And for that, you need to replace mu by lambda and sigma square by lambda. Because in Poisson, both mean and variance are same. So this is the distribution, normal approximation. And this is the formula of Z. This is the continuity correction. Now, distributions of sample means. And for these types of questions, you must be good at sampling. So x bar is approximately normal and mean is mu naught and variance is sigma square over ns. Let me show just one table. Sampling summary, and you just need to see this table. This one. I'm not discussing this here, I'm just showing this. When do we apply CLT? When the population is normal. When the population is normal, we never apply CLT. And when the population is non-normal with n is large, then we always apply CLT. So you must be good at sampling. For testing, the background knowledge is sampling and binomial and normal and Poisson distributions. If you are good at sampling, then you will be good at testing. Otherwise, it would be very difficult to handle testing of hypothesis. So if population is distribution of sample mean is normal, this is the formula of z-test. You just need to write mu naught here and this in square root. Square root of this is sigma upon under root s. Go through my notes of sampling. Okay, that's it. This is the review. Now, let me discuss important questions of testing of hypothesis. I'm sorry. Okay, just 1 minute break and then I will start this. This is my worksheet and I will give you the link of this worksheet after this lecture in the description. It's a 20 minute break. 20 break. So I'm taking that break. So you have 1 minute break. Well, I will explain type 2 error in normal distribution later in this lecture, inshallah. For that, we will first find critical region and then we will find probability of type 2 error. Don't worry, I will discuss this. I'm sorry. Okay, question number 1. I'm trying to discuss more questions, inshallah. At a certain hospital, it was found that probability that a patient did not arrive for an appointment was 0.2. So this is binomial because there are two outcomes: patients who arrive and patients who do not arrive. So H naught is P 0.2. The hospital carries out some publicity in the hope that this probability will be reduced. So this is very important. Lesser sign. So this is H1. P has decrease. Okay, you should write in words decrease. I'm just saving time. But in CIs, you have to write decrease here. Okay, a random sample of 30 appointments. This is N of binomial is selected and the number of patients do not arrive is noted. This figure is used to carry out a test at the 5% significance level. So alpha is 5%. I'm sorry. Explain why the test is one-tailed and state suitable null and alternative hypothesis. We already have mentioned H0 and H1. Now, why the test is one-tailed? Because we are looking for a decrease in P. It is one-tailed because we are looking for a decrease in P. That is why it is a one-tailed test. Decrease in P. Use a binomial distribution to find the critical region. I told you this is the discrete distribution. So for critical region, we will use trial and error method. I'm writing this here. Use trial and error method. And find the probability of type 1 error. The probability of critical region is the probability of type 1 error. It is a lower tail test. So critical region is on left side. This is the critical region with probability 5%. Remember, the first value will always be in critical region. This must be in critical region. One value is always in critical region. Now we have to check whether 1, 2, 3, 4 are these values in critical region or not. So you have an option. You can start with 1 or 2. If probability is large, like 5% is the large probability as compared to 2%, so you can start with 2. I mean, you have to do trial and error. So you have option. You can either start with 1 or 2. So I'm starting with 2 because this probability is large. There is no problem. You can start with 1 as well. So let x be 2. So check this probability. X less than equal to 2. Why less than equal to 2? Because it is a lower tail test. So when a test is lower tail, always write less than equal. So 0, 1, 2. So use binomial. So 0 means q power 20. 1 means 20c1, p power 1, q power 19. Then 20c2, p power 2, q power 18. In order to save time, I'm writing this answer here. This number where p is 0.2, this is q, this is p, this is p, this is q. So this result is 0.0442, which is in percentage is 4.42%. So this probability is less than 5%. It means 2 is in critical region. 2 is in CR. CR means critical region. Now let's try 3. So write this as x less than equal to 2 plus x is equal to 3, because we already have found this probability. It's 0.0442. Just find probability of 3, which is 20c3, p3, q17. This is 0.8. Now this probability is 0.123, which is 12.3%. So greater than 5%. Therefore 3 is not in critical region. So the critical region is x less than equal to 2, or you can say x is equal to 0, 1, 2. I'm sorry. Therefore probability of type 1 error is the probability of critical region, which is x less than equal to 2, which is 0.0442. That's the answer of part B. Now the next part. In fact, 3 patients out of 30 do not arrive. So this is the test value. The test value is 3. State the conclusion of the test explaining your answer. You have to write as 3 is not in critical region, therefore accept H0. This is the critical region. 1, 2 and 3 is here. So 3 is not in critical, so accept H0. And what was H0? H0 was P is 0.2. And H1 was P is less than 0.2. Now you have to conclude this. You have two options. Number 1, you can say accept H0 means insufficient evidence to conclude that P is less than 0.2. There are two ways. I'm writing both. No evidence except H0 means no evidence to say that P is less than 0.2 or P has decreased, you can say, or P has decreased. The other way, you can say accepting H0 means evidence that P is 0.2. You have both the ways. If you are accepting H0, you can conclude in this way. You are rejecting H1. You are rejecting P less than 0.2. So you have to say no evidence that P is less than 0.2. Or you can conclude in this way as well. Evidence that P is 0.2. So you can give your answer in any way. But this is the best way. Accepting H0 means conclude in this way. No evidence that P is less than 0.2. Now, question number 2. I hope you are understanding this thing and there is no problem. If you will find any difficulty, you can just write in comment sections. I will explain that thing again. Alright, so the mean weight of bags of carrots is mu kilogram and inspector wishes to test whether mu is 2.0. This is a two-tailed test, whether 2.0 or not. So H0 has a not equal sign. H1. This is H0 and this is H1. And this is the sample size. This is the data for unbiased estimates. So we have to find unbiased estimates here. So mu cap x bar sigma x over n. This is 430 over 200, which is 2.15. Now sigma cap square. It's n upon n minus 1 sigma x square over n minus square of mean. So this is 200 upon 199 1290 over 200 minus 2.15 ka square. So this is 731 over 398. Write the exact value of this. If it's in decimal, then write the complete value. Now we have to write H0, which is mu is equal to 2.0. H1, mu is not equal to 2.0. So mu has changed. Here you can write mu has not changed. This will help you to write type 1 and type 2 error in words in the context of the question. Now, since n is large, greater equal to 30, n is 200, and population is unknown, therefore, according to CLT, the distribution of sample means is approximately normal. Write mu naught here, sigma cap square over ns. This is the distribution of sample means. Now x bar is normally distributed, mu naught is 2.0 and sigma cap square is 731 over 398 times ns. Now find z test. It's x bar, which is 2.15 minus mu naught 2.0 and square root of this. So this value will be 1.565. Now find z critical. It was given we have to perform this test at 10% and it's a two-tailed test, so 5% on both sides, and the 5% value is 1.645. So this is minus plus 1.645. Now this value 1.565 is less than 1.645. This is here in accepted region. So accept H naught. No evidence to say or conclude that mu has changed because we have accepted H naught. Okay, I will try to solve one question of type 2 error. It's in my notes. So yes, type 2 error, but this question is of Poisson distribution. This is not of normal. Someone asked me to solve a question of type 2 normal distribution. Yeah, this is a question of type 2. Okay. A type 2 error in continuous distribution. The masses in grams of apples from a certain farm have mean mu and standard deviation 5.2. The farmer says that the value of mu is 64.6. So H naught is mu 64.6. H1 mu. A quality control inspector claims that the value of mu is actually less than 64.6. So less than 64.6. Mu has decreased. Mu has not decreased. So in order to test his claim, random sample of 100. So this is NS. The mean mass of the 100 apples is found to be 63.5. 63.5. This is sample mean and test value. Carry out the test at the 2.5% significance. So distribution is unknown. So according to CLT, distribution of X bar is normal because N is large. So mu naught is 64.6, variance 5.2 square over 100. Now Z test. It is X bar, which is 63.5 minus mu naught over under root 5.2 square over 100. So this will give you Z test. Now Z critical at 2.5%. So Z test is minus 2.115 and that is minus 1.96. Minus 2.115 minus 1.96. So minus 2.115 is less than minus 1.96. It lies in critical region. This is here. So reject H naught. Evidence that mu has decreased. We rejected H naught, that means we accepted H1, and that means mu has decreased. Now the second part of this question. Later, another test of the same hypothesis at the 2.5% significance level with another random sample of 100 apples from the same farm is carried out. Remember, for type 2 error, they will always give you a new mean. This is a new mean. And remember, we use this value only for type 2 error probability. We never use this value for critical region. For critical region, we use value of mu naught. For type 2 error, we need critical region. We need C. And for that, we need to use this formula Z test, Z critical. So C minus mu naught. Remember, we write mu naught here. And mu naught was 64.6. And the other thing is variance is 5.2 over 10 under root. That is the standard deviation. And 2.5% value was 1.96 minus. Now find C. This is the critical value. This number is 63.581. Now understand this here. This is the critical region, 63.581. This is the rejected region and this is the accepted region. This is the region of type 2 error. So probability of type 2 is the probability of accepted region, meaning x bar greater than 63.581. This is the region of type 2 error. Now remember, you have to use new mean here, and this is the new mean, 62.7. Use this value here. (62.7) and standard deviation was unchanged. So this will give you probability of type 2 error. This number will be, you can see this here. See, this is the new mean. This is the standard deviation over NS. 5.2 over 10. Now this is the number 1.694. This is 1 minus 5, and this is the probability of type 2 error. This is the way to find probability of type 2 error. You can check this again. First, work for critical region, and while working for critical region, use mu naught here. Never use this new mu. We find critical region with the help of mu naught. Once you get the critical region, then you can easily find probability of type 2 error. It is the probability of accepted region, meaning greater than 63.581. And this is the way to get the probability of type 2 error. I hope this lecture will help you to understand few concepts and few questions of testing. You can watch my lectures. You can just check the playlist and watch my lectures on testing. There are a lot of lectures on testing and questions, and I hope you all will do well in your S2 exam. Good luck.